At the center of a galaxy 70 million light-years away, there's a bar. At the center of the bar, a smaller spiral. And at the center of that spiral, a supermassive black hole. This is NGC 1300, a cosmic puzzle that challenges everything we know about galaxy evolution. What shapes a galaxy? The answer lies in barred spirals like NGC 1300, where a massive bar of stars and gas funnels material inward, potentially feeding a supermassive black hole. This video explores one of the most detailed Hubble images ever taken of a complete galaxy, revealing how bars form, why they persist, and how they influence star formation, an active area of research with implications for understanding our own Milky Way's evolution. NGC 1300 is a barred spiral galaxy located 70 million light-years away in the constellation Eridanus. It spans over 100,000 light-years, roughly the size of our Milky Way. What makes it extraordinary is its structure. A brilliant central bar that cuts across the galaxy's core, with spiral arms unwinding from its ends. This Hubble Space Telescope composite is one of the most detailed images ever made of a complete galaxy, revealing striking details from the bar to the outer arms. The bar is not just a static feature, it's a dynamic engine. Astronomers believe bars are density waves that channel gas and stars inward. Over millions of years, this process can funnel material toward the galactic center, potentially triggering star formation and feeding the supermassive black hole hidden at the core. The bar in NGC 1300 stretches about 27,000 light-years from end to end, a substantial fraction of the galaxy's diameter. Inside the bar, Hubble's image reveals an even more surprising detail, a smaller spiral structure. This inner spiral, only a few thousand light-years across, wraps around the very center of the galaxy. It's a galaxy within a galaxy, a rare and beautiful phenomenon. The inner spiral is likely a result of gas being funneled by the bar and then settling into a rotating disk that forms its own spiral arms. At the heart of that tiny spiral lies a supermassive black hole. With a mass millions of times that of our Sun, it exerts a powerful gravitational pull. But unlike some other galaxies, NGC 1300's black hole appears relatively quiet, not actively feeding or producing jets. This suggests that the gas funneled by the bar may not always reach the black hole, or that it is inefficiently accreted. Bars are common in spiral galaxies. About 2/3 of all spirals have one. Our own Milky Way is thought to be a barred spiral, making NGC 1300 a valuable analog for studying our home galaxy's structure. The Milky Way's bar is estimated to be about 30,000 light-years long, similar in scale to NGC 1300's bar. By studying distant barred galaxies, we can infer the past and future of our own. How does a bar form? One leading theory is that it emerges naturally from gravitational instabilities in the rotating disk of a galaxy. Stars and gas accumulate into an elongated structure that then grows over time. But bars can also be destroyed or weakened by interactions with other galaxies. The exact conditions that determine whether a bar forms or dissolves are still not fully understood. Once formed, a bar can last for billions of years, but not forever. Over time, it may dissolve as it transfers angular momentum to the surrounding dark matter halo. The fact that we see so many barred galaxies suggests bars are long-lived, but their evolution remains an active area of research. NGC 1300's bar appears robust and well-defined, indicating it is likely in a stable phase. The bar's influence on star formation is profound. It funnels gas into the central region, compressing it and triggering bursts of new stars. In NGC 1300, the inner spiral is dotted with bright blue star clusters, signs of recent star formation, likely fueled by the bar. These clusters are young, hot stars that shine brightly in ultraviolet light, visible in Hubble's detailed image. But not all gas is turned into stars. Some continues inward to feed the black hole. Why some bars feed black holes efficiently and others don't is a puzzle. In NGC 1300, the black hole is dim, suggesting either a lack of fuel or inefficiency in the accretion process. The bar may be diverting most of the gas into star formation rather than allowing it to reach the center. The Hubble image of NGC 1300 is more than a pretty picture. It's a scientific treasure trove. It combines multiple exposures to capture both the bright core and the faint, dusty spiral arms. The resolution is so fine that individual star clusters and dark dust lanes are visible across the entire disk. By studying such detailed views, astronomers can test models of galaxy evolution, bar dynamics, and black hole growth. One of the key questions researchers are investigating is how the bar in NGC 1300 maintains its shape over time. Bars can be weakened by the very gas they funnel, as the gas transfers angular momentum back to the bar. Understanding this feedback loop is crucial for predicting how long bars last and how they impact galaxy evolution. NGC 1300 also serves as a reminder of the scale of the universe. 70 million light-years away means the light we see today left the galaxy when dinosaurs roamed the Earth. The Hubble image captures a single moment in the galaxy's history, but the processes it reveals operate over millions of years. Every detail, from the tiny inner spiral to the grand outer arms, tells a story of cosmic evolution that is still being written. The inner spiral within the bar is particularly intriguing. Only a few galaxies are known to host such nested structures. It may represent a transient phase where the bar has not yet fully dissolved, or a sign of ongoing gas accretion. Studying NGC 1300's inner spiral could provide clues about the formation of nuclear rings and active galactic nuclei. NGC 1300 is a cosmic laboratory for understanding the role of bars in galaxy evolution. These structures are not mere decorations. They actively reshape galaxies by channeling gas, triggering star formation, and feeding supermassive black holes. Yet many mysteries remain. Why do some bars last for billions of years while others fade? Why do some black holes feast while others starve? The answers lie in the interplay between gravity, gas dynamics, and dark matter. Our own Milky Way is barred, so understanding NGC 1300 may offer insights into our galaxy's past and future. The Hubble image captures a single moment in time, but the processes it reveals operate over millions of years. Every detail, from the tiny inner spiral to the grand outer arms, tells a story of cosmic evolution that is still being written. By studying galaxies like NGC 1300, we get closer to understanding the fundamental forces that shape the universe and our place within it. So, what other secrets are hidden in the bars of distant galaxies? If you enjoyed this cosmic journey, subscribe and hit the bell to explore more wonders of the universe. Leave a comment. Do you think our Milky Way's bar will persist or eventually dissolve? See you in the next video.